Hey guys, today we are going to do activity 25-1, and 25-3, square root and cube root functions. First, I want to go over the transformations again. So remember, if you have a value that's being multiplied out in front of your function, that's going to show a vertical stretch or shrink. If you have a number being added or subtracted inside the function with x, that's going to be a shift left or right. If you have a value being added or subtracted to the function at the end of it, it's going to be a shift up or down, and then a negative out in front of your function, it will be a reflection over the x-axis, okay? All right, so example 1, we're going to graph the square root functions and state the domain and range, and also I want you guys to list the transformations, okay? The parent function of a square root function looks like this. We've all seen something like this before, right? So for the parent function, let's go ahead and look at just what that looks like. Notice that the negative x values don't exist there because if I take the square root of a negative, if you remember from the past that the square root of a negative gives you an imaginary number, right? So we're going to use the x values of 0, 1, and let's use 4. Okay, the square root of 0 is 0. Square root of 1 is 1, and the square root of 4 is 2. I wanted a nice pretty number there, that's why I use 4, and you guys can see this in your table values. 0, 0, 1, 1, and 4, 2. Okay? Alrighty, so we're going to use that as our parent function graph. Now, if you are in Honors Algebra 2, you will be doing these by hand. If you are in regular Algebra 2, you can graph this on your calculator. Okay, but everybody needs to be listing the transformations and stating the domain and range. So real quick, I'm going to rewrite the parent function down here. Okay, now let's talk about what these transformations are going on here. We've got a 2 out in front, which will mean we have a vertical stretch by 2. And this minus 3 right here means we're moving to the right by 3, because remember, if that's a minus sign, that's to the right. If that's plus, it's to the left because it's attached to the x. All right, so let's go ahead. Remember the order of the transformations, you go right or left first. So I'm going to do this one first. I'm going to take my x values and add 3 to them because that will move them to the right by 3. And a vertical stretch by 2, that affects your y values. So you're going to multiply them all by 2. And it talks about that, which values it's going to affect the transformations up at the top in the descriptions, if you need to refer back to that. So 3, 4, 7, 0, 2, 4. All right, so that's all the transformations. I'm going to go ahead and plot it. There we go. There's my graph. Okay. Now, if you are in regular Algebra 2, I'm going to show you how to type this in your calculator. Y equals, we're going to do 2 square root of x minus 3. You guys can see that those graphs look exactly the same. And regular Algebra 2, you can go into the calculator and just plot those points. Okay? All right. So, from here, let's see. The domain, or our x values, my most left x value is 3. It starts at 3. Okay? And then it goes all the way to the right towards positive infinity. Now, this 3 is included. It is a coordinate point, so we can put a bracket on that guy. But remember, always use a parenthesis on infinity symbols. Now the range, it goes from 0 to positive infinity, from the bottom to the top. My most bottom y value is 0, and that is part of the function. We have a closed dot there, so we can put a bracket on it. Okay? Alrighty, letter B. So my parent function, 0, 1, 4, 0, 1, 2. Alrighty. It looks like my function's only just moving up by 4. That's the only transformation I have there. So I'm going to take my y values and I'm going to add 4. The x values stay the same, and I get 4, 5, and 6. Right? 4, 5, yep, okay. All right, let's plot those points. 0, 4, 5, 1, 2, 3, 4. Okay, and connect your dots, and voila. Again, if you're in regular, I'm going to show you how to type this in real quick. Y equals, we have the square root of x. And see how the plus 4 is not underneath the radical? Make sure that you're outside of the radical before you add 4. And then you can see that your graph looks just like ours. Okay? And make sure, look at the table values, plot the points. Alright, so from here, the domain, my most left x value is 0, and it's included, so I put a bracket on it, and it goes all the way to positive infinity. My range starts at 1, 2, 3, 4. The lowest y value is 4, and then it goes up towards positive infinity, and that point is included, so we're going to use a bracket. Okay? Alright, so that's square root functions. Now to the cube roots. Alright, we're going to graph the cube root function, state the domain and range, and I want to also list the transformations. Okay? Alrighty here. So a cube root function looks like this. You're taking the cube root. The square root, that looked like this, right? And there's actually a 2 right there that's like unknown. Well, people just assume there's a 2 there, okay? So that's just like a known 2 to be there. So that's why that was the square root. But anyways, cube root functions. Let's look at the graph of a cube root. Now to type the cube root function in, you guys can hit math and number 4. It already has the cube root there. Almost looks like a squiggly, right? Oop. Okay, so this is a cube root function. Looks like we have 1, 2, 3, 4, 5 points. So let's do 0 right here, like right in the middle. Let's get that, and then let's do 2 points to the left and 2 points to the right of it. So what are some pretty numbers from the parent function? It looks like we don't have any pretty numbers. So let's use -1 and 1. That might give us off the graph. Let's go ahead and use like -4 and 4 then. Okay, so -4, we got -1.587, -1, -1, 0, 0, 1, 1, 1.587. The reason why I didn't want to use the 2's is because, like, oops, they would be like way too close right here. It wouldn't give me a really great picture. So I'm gonna like extend it a little bit so I can get a better picture of my graph. Okay, I won't take points off for you using different values here, but at least use -1, 0, and 1, and then just pick another x value there. Okay. All right. So letter A, regular algebra 2. Again, you guys are still just graphing these on your calculator. Okay. Honors, you gotta do this by hand. So letter A. Oh, we've got lots of transformations. We've got 1, 2, 3 transformations here. Remember, this is not -2. You have to think of this negative as its own transformation and the 2 as its own transformation. So we have a reflection over the x-axis. Okay. And then we have, remember, that negative got taken care of by the reflection, so now we're just focusing on the number 2. So it's positive, it's greater than 1. It's a vertical stretch by 2. And this is inside of the radical, so this will be right 2. Good so far? Alrighty. So let's see. Let's write out our parent function. -1.587, 1, 0, 1, 1.587. Alrighty. So let's see here. You remember we always got to go left or right first, so the x values we're going to add 2 to those because that will do the right 2. Okay, and then the reflection in the over the x-axis and the vertical stretch by 2, that means we're going to affect the y values. You're going to multiply the y values by 2 and also by -1, so you could just say just multiply these by -2 if you want. Okay, and let's graph it. Alright, so these are all by right 2. So this will be -2, 1, 2, 3, 6, right? 2, 3, yep, okay. And then these I'm going to multiply by -2. So -1.587 times -2, 3.174. This will be +2, 0, -2, and this will be just the negative version of what was up there. Okay? Alrighty, and that's all the transformations. So let's graph it. Alright, -2, 1, 2, 3, 0.1, we've got 1, 1, 2, we've got 2, 0, 3, -2, 6, -1, 2, 3, 1. Alright, so as you guys could tell that the parent function kind of looks like a squiggly, right? But this is being reflected, so over the x-axis, that's why it looks the opposite way. So it goes down like this. Okay? Real quick, if you are typing that into your calculator, this is -2 math 4 x minus 2. You guys can see it looks just like that. Okay, and you guys can plot those points, and you guys can see here that these are the same points that we plotted. Okay? Alright, the domain. My most left x value goes to -infinity, and my most right value goes to +infinity. So it looks like that. And then my range, my lowest y value, well, if these keep continuing, they're going to eventually start to go down. So this is actually going from negative to +infinity as well, because nothing's stopping them. We got arrows. Okay? So all real numbers for both of those. Alright, letter B. One more. So we've got a vertical stretch by 2. And up 3. So let's write out our table of values. Okay. All right. I need to, okay, these both are going to affect our y values. The vertical stretch, we multiply our y values by that, and then up 3, we add 3 to the y values. So, but we have to do the vertical stretch first and then do the up by 3, okay? Just because of the order of transformations. Alrighty, so let's take these y values and multiply them by 2. And I'm just going to say what those equal right here. Miss Wade does this sometimes, I know. Alright, so this will be, let's see here, negative 1.587 times 2, that will be negative 3.174. I guess we kind of did that already on the last problem. Alright, so negative 2, 0, 2, 3.14 or 74. Alright, and then we're going to take those y values and add 3 to them. So So that's going to give us, let's see here. Oh, whoops, sorry, paper got all crooked. So when we add 3, it's going to give you negative 0.174. That'll give you 1, 3, 5, 6.174. I'm going to double check my math real quick. 1, 3, 5. Yep, okay. So these are my table values. So negative 4, negative 0.1, 2, 3, 4, negative 4, negative 0.0. Okay, so it's going to look like that. I have negative 1, 1, 0, 3, 1, 5, and 4, 1, 2, 3, 6.1. Something like that. All right, so it looks like my graph's going to go in that direction. So let's see if I can do this nice and pretty. There we go. Okay. Alrighty, and if you are graphing this in your calculator, so we've got 2, math, whoops, number 4, x plus 3. Make sure you get that, move your arrow before you do the plus 3 so it's not under the radical. And there we go. Look at your graph. Look at our table of values. Look, we got the 0, 3, we got the negative 1, 1, we got the 1, 5, okay? So if in regular, make sure you guys are just plotting those points that you see off the table, okay? Now the domain of this function, it goes from negative to positive infinity, nothing's stopping it. And the range, bottom to the top, my lowest y value just keeps going down to negative infinity, and my highest y value goes towards positive infinity. And that's it, guys. All right, so let us know if you have any questions. Okay, see you later.